Big O notation is a very confusing concept, and many times students get confused what exactly they are all about. Of course, this is a very complex mathematical topic, but we'll not get into much details here because I believe once you are aware of the concepts, it's easier to go deeper. So let's start. Before we dig into Big O notation, we should know what exactly is an algorithm. In mathematical and computer science, an algorithm is a finite sequence of well-defined, computer implementable instructions, typically to solve a class of problems or to perform a computation, right? This is the bookish definition. In simple words, we can say an algorithm is a step-by-step instruction to solve a problem. An algorithm is a step-by-step instruction to solve a problem. So now we know about algorithms. So let's move to the big O notation. Big O notation is essentially measuring the rate of growth in time for an algorithm with reference to the size of input. Big O notation is essentially measuring the rate of growth in time for an algorithm with reference to the size of input. So suppose you have a solution of a particular problem. Your solution might work for number of inputs, say 5. And suppose when you are entering 5 numbers, your solution takes 5 minutes. How about if we increase the number to 100? Now it will take more time. And if we keep increasing the numbers, it will take more and more time to solve the equation, to solve the problem. So Big O notation, it measures the rate of growth in time. So how your solution behaves with the increasing of input. So big O notation have several notations. The first one is big O of n, where n is the number of input. Second one is big O of 1, big O of n square, big O of n cube, and big O of n, which is called exponential. So we'll discuss all these notations one by one. So let's start with big O of n. Big O of n is called linear growth. Suppose you have a method or a function where there is a single loop and it is iterating the array. So what happens when your array size is limited? Say you have 10 elements in the array and you want to find a particular element. So how much time it will take? It will, let's suppose it will take 5 minutes again. Now what happens if the array size increases? Like if number of inputs are increasing, it will take more time to process this function. So this is called linear growth, big O of n, because time is increasing as we are increasing the number of inputs. Now let's move to the second one, constant growth, order of 1, big O of 1. Big O of 1 is something, whatever input we put in a function, the amount of time it takes is same. Whether we are entering 5 input, we are increasing 1000 or 10,000. The time doesn't increase. So what is the example of this? Suppose you have an array and you know the index, and using that index you want to fetch that element which is available on that index. So what will it will do? Suppose we have a get value function and you are putting the array and the index as parameters. Suppose you have an array of size 5 and you have 5 elements and you want to fetch the element at index 2. So it won't take much time because you know the index. Suppose the size of array increases to 100 elements. What will happen? Again, if you know the index, it will take same time because you do not have to iterate over the array. In earlier case in the linear growth, we had to reach each and every element, but since we knew the index, We do not have to iterate. We just get the value using that index. So it doesn't matter what the size of our array is, as long as we know the index. So this is constant growth and it is denoted by big of 1. Let's move to the next notation. The second one is quadratic growth, big of n square. So here's the example you have. You can see you have two loops, loop within a loop. So this notation denotes functions when you have multiple loops, possibly two loops. So suppose you have 5 elements in loop 1 and 5 elements in loop 2. So how much iterations it will manage? It will manage 5 into 5, 25. So it is a little bit slow than the linear growth. As long as you are increasing the input size of array, it will take double time to process the function. Let's move to the third one. Third one is cubic growth, big of n cube. So you can like find this problem where you have 3 different loops. So in 3 different loops, it will take, suppose you have 5 elements in loop 1, 5 in loop 2, and 5 in loop 3. So how much iteration it will take? It will take around 5 into 5, 25 into 5, 525 iteration, right? So this type of solution is considered quite slow. Now the last one is exponential growth. So what exactly is an exponential growth problem? So the problem where you do not know how many loops you need to put in order to solve that problem. Because you do not know, you might have more than 3 loops, you might have like 5 or 10 loops. So the time grows really high. So in this type of problems are called exponential growth, big of n cube. So we have seen how all the big O notations work with respect to time whenever we are increasing the input size. So this is a summary of all the notation that we covered. We have big O of 1, big O of n, which is linear, big N square, quadratic, big O of n cube, which is a little bit slower than the quadratic one, and big of n, which is exponential growth, which is very, very slow. So whenever we are writing a program, we are writing a solution, we should consider all these things in your mind so that you can write efficient solutions. So guys, that's all we had in this tutorial. I hope this tutorial helped you to have some better understanding of Big O notation. And if you find this video helpful, please subscribe to my channel. Thank you guys.